So you want to know about another magic property of H2O, how it absorbs and emits radiation energy. Let's start by describing how energy works. Describe the energy path here.
Electrical energy from the plug goes through the wires and lights the lamp.
And then here?
A cell tower sends out energy as radio waves to a cell phone.
Good. And now we see energy from the sun reaching Earth. Each of these is an example of electromagnetic radiation energy. It is generated by a source, it is transmitted, and then it reaches something that absorbs the energy, like a light bulb or a cell phone. Some radiation, like that of the sun, is given a special term. We call it thermal radiation. Scientists have discovered two important things about it. One, solid objects emit thermal radiation. The sun, wood in a fire, even our bodies. We can see some of this radiation. We see the sun, and we see the red glow from a fire. But a lot of thermal radiation we cannot see, like the radiation coming from you. But it's there. Two, things can absorb thermal radiation. Your body absorbs sunlight. You can feel it warming your skin. That's why we call it thermal radiation. It raises the temperature of an object. So by now you are wondering, what does all this have to do with H2O? You know that the sun warms liquid H2O, water, and the sun can melt frozen H2O, ice. But what about H2O as a gas, as water vapor? Gases don't absorb and emit thermal radiation like solid objects. They act differently. Ultraviolet sunlight is absorbed by ozone high in the atmosphere, and water vapor absorbs a fraction close to the Earth's surface. But most sunlight on a cloudless day reaches the surface. It is just a phenomenon of nature. On land, almost all the sun's energy is absorbed by what's on the ground, such as rocks, soil, and sand. The ground quickly becomes much warmer than the air, and dark things like pavement and beach sand actually get hot. The ground transfers heat to the air in two ways. First, it conducts heat directly into a thin film of air. This creates packets of air that are warmer than the air above, so buoyancy causes them to rise upward. This is convection heating. The second way is because warm ground and hot sand emit infrared thermal radiation. The two main gases in the air, nitrogen and oxygen, don't absorb infrared radiation, but water vapor absorbs much of it. It's another reason why we call it a magic molecule. After water vapor absorbs the ground's thermal radiation, it transfers the energy to surrounding air molecules. Over most of the world, water vapor is plentiful, so it absorbs all the surface radiation close to the ground and adds to heating by convection. This is what happens on land. But earlier I described what happens on the oceans. Do you remember?
There is only water to absorb the sun's energy. Unlike on land, most of this heat is not conducted to the air above. Instead, the absorbed energy greatly increases the amount of evaporation.
That's right, and because the air over oceans over most of the Earth is at nearly the same temperature as the water, water vapor radiation absorption has little effect. So now I hope you see why I call H2O the magic molecule.